Welcome back to APES Review, Estudiantes. Let's get started with Unit 3 on populations. All right, so this video will hit on both concepts associated with population in ecology and the human population. So remember that there are generalist and specialist species. Specialists have a smaller range of tolerance. They're have a very specific food requirement. They're less adaptable to new environments and thus more prone to extinction. And generalists have a much broader niche or ecological zone of tolerance and are more adaptable and less prone to extinction. And here's just some of the aspects associated with both organisms that we consider specialist and generalist. Generalists, remember, tend to thrive in areas around humans, and specialists are more prone to extinction because they're less likely to adapt. We can also refer to species by how they reproduce. And so there's both K and R selected. R selected are your roaches, K selected are your kangaroos. Another way of saying that is K selected individuals. They have fewer offspring, usually later in life, and they give parental care to those offspring. And so they have a low biotic potential, which biotic potential is just the ability to reproduce a lot of organisms at the same time. Whereas R selected, they produce a lot of offspring and don't care for that offspring. Examples are things like fish, some plants, a lot of flowering plants, especially in insects. These are going to be better suited for a rapidly changing environment because they often have a shorter lifespan. And here's a table that illustrates some of the differences between R and K selected organisms. Invasive species, sorry, I'll come back to this way. Invasive species are often R selected because they are going to reproduce faster, and so they can spread out faster in an area. Okay, survivorship curves. We can also talk about R and K selection in terms of survivorship strategy. And so just remember that type 1 survivorship is essentially K selection. We are type 1 survivorship, fewer offspring. Most of the young survive, and then some of the young don't. Whereas type 3 survivorship is akin to R selection. Lots of offspring, most of them die the very early stages of their life because they have no parental care. And then there's type 2 survivorship, which is where you have all individuals have kind of an equal chance of dying at any life stage. And here's just some words about that in case you need to jot down some words about survivorship. Carrying capacity. This is the amount of organisms that an environment can support based on limiting resources. And so let's talk about some of those density dependent factors here. So we have what we're seeing right here is carrying capacity results in what we call logistic growth, or an S-shaped curve, where the population levels off at a carrying capacity. Okay, you could overshoot the carrying capacity. If you have a sharp, big overshoot of the carrying capacity, you can then have a large die-off because you have too many organisms in the environment. And here's an example of that with reindeer in St. Paul Island. You can also have a fluctuating carrying capacity if it's a predator-prey relationship, and the amount of lynx are going to be dependent on the hare. And so this will be changing as you go through time, and the hare population goes up and down and the lynx population goes up and down in response to that. Okay, when we're talking about populations, we want to talk about how they're distributed, right? We talked about random, uniform, and the most common in nature, which is a clumped distribution. But we can also look at it in terms of the size, the total number of individuals, density, the individuals per area, if you're asked to do that type of calculation, and then the distribution, which we just mentioned, the three main distribution patterns. Things that influence populations are the sex ratio, how many males compared to how many females, and then both density dependent factors, which are things that pressures that increase in how they pressure based on the population size. So like if there's more organisms, there's going to be less food per organism. There's going to be more competition for habitat. All of these resources that are density dependent versus a density independent limiting factor would be something like a natural disaster, which it doesn't matter how big or small the population size, the incident will limit them regardless of population size. Okay, so just some new words here. Biotic potential, right? That's when a population can grow to its maximum rate, right? So that is essentially exponential growth. When a population grows to its biotic potential, and logistic growth is where population starts growing quickly and then slows off as it approaches its carrying capacity. For calculating population change, remember that we just add immigrants plus births minus emigrants plus deaths. And if you want to turn that into a rate, you can then divide by the total population, and that will give you a rate. We describe human populations often with age structure diagrams. And so if you have a bottom heavy pyramid, that means you have a lot of people coming into a reproductive ages. And so that's going to be a very rapidly growing population. And on the left side, we see the pyramid there, Guatemala, Nigeria, and Saudi Arabia. That population has a lot of what we call population momentum. And then we have an expanding population, which you can see what that pyramid, it still is wider on the bottom and skinnier on the top. Stable population is going to be about the same width on the bottom as it is in the middle. And then a declining population is going to have less individuals in the pre-reproductive age. And this is in many developed countries that have been developed for a long period of time, such as Germany, Bulgaria, Italy, and Japan. And these are just some more examples of age structure diagrams. Okay, so just make sure that you can read these and identify how the country is growing based on the age structure diagram. So the slowest rate of growth here would be the pyramid that is the least bottom heavy. That would be the middle one. The total fertility rate, right? This is the number of children per woman. And then we have replacement level fertility, which in most countries is around 2.1. And that's the number of offspring a woman needs to have for a country to maintain its birth rate. And then infant mortality rate, which is often responsible for a lot of death in developing countries, is another term here. So here we can see in less developed countries, we have higher infant mortality rates and higher higher total fertility rates, which those almost cancel each other out. And that is something that we'll look at in demographic transition here in just a few minutes. Things that affect infant mortality: access to hospitals, clean water, right? A reliable food supply. Those are all going to decline if you don't have them. And factors that affect total fertility rate, right? These are the pro and the anti-natalist factors here, right? So countries that give women more access to education and contraception, and women get pregnant later, and you don't need children to care for the farm, those are all going to result in lower total fertility rates, right? And typically there is relationship between the affluence of a country and total fertility rates. Usually higher affluence means lower total fertility rates as well. This higher female education, lower total fertility rates. So let's get to human population. There's kind of two theories for the human carrying capacity. Malthus theorized that there is a carrying capacity on Earth, and it's decided by the amount of food. But then there's also the idea that technological advancement can increase the carrying capacity. An example of that would be when we learned how to fix nitrogen from the atmosphere using the Haber process, which did increase the food supply. So if we're calculating growth rate is just going to be the births plus immigrants minus deaths plus immigrants divided by the total population, and then times 100%. That'll give you your growth rate. But often we're given growth rates in crude birth rate and crude death rate, which, remember, that's just per 1,000 people. And so you can just divide the raw numbers, CBR minus CDR, and you can divide that by 1,000 and then multiply by 100 to get to a percent. Or some people just shortcut it and use it divided by 10, since you're dividing by 1,000, then multiplying by 100. It's the same as dividing by 10. The rule of 70, I would encourage you to use this. This is doubling time. So the time it takes a population to double is equal to 70 divided by the percent growth rate. And this could be used. You could ask to be solved for the doubling time, or you could ask to be solving for the percent growth rate, any of those. Okay. And then the factors that affect a growing human population, we've talked about a lot of these, but a lot of it has to do with things like standard of living, gross domestic product, life expectancy, right? These are all going to be standard of living indicators. And I think it's best to discuss these when we talk about demographic transition, which, remember, these 4 stages of demographic transition. And let me go back to this graph here, right? So we start with stage 1, high birth rates, high death rates. That's low access. This is stage 1, which we call, which we call the pre-industrial phase. This is in developing countries, right? When they're growing fast, high birth rates, high death rates. And then the death rates drop as infant mortality decreases in stage 2, but birth rates stay high. And then in stage 3, women start gaining access to the workforce, and thus birth rates drop as well. And so in stage 4, the population finally begins to level out. And then in stage 5, we'll even see a population that is beginning to fall as we go through what we call demographic transition. Okay, and a big part of this demographic transition is industrialization, right? And so in stage 1, that's our pre-industrial. You can write some of these things down that result in high birth rates, high death rates. Stage 2, industrializing, developing. This is when our infant mortality drops, but total fertility rates stay high. And then stage 3 is when we have our developed or industrialized, and the birth rate drops closer to the death rate. And then finally, our post-industrialized, highly developed is when the overall growth rate levels out and the population even starts to decline. So feel free to jot down anything you see on those slides that you did not know. Okay, and that is it for Unit 3. Fantastic. Next, we're off to Unit 4. All right.